Good afternoon to all participants. Welcome to 7 Days Faculty Development Program through virtual mode on research methodology for social science. And today is day 5 session on topic hypothesis testing. And our resource person for this session is Professor Anand from Department of Business Studies, School of Arts and Science, Sri Manakula Vinayagar Engineering College. He holds an MCom in Business Finance from Pondicherry University with distinction. He aspires to excel in the field of academics and research. His area of interest is in business analytics, finance, financial modeling, and investment. He represents the institution's commitment in teaching and research contribution to the society. He is a strong believer in an educational system that promotes professionalism among the student community by identifying and motivating the students with creativity, innovation, and entrepreneurship. Let us start the session. Anand sir, you can carry on.
Thank you, ma'am. Good afternoon, everyone. I am delighted to be here today to discuss an integral part of research methodologies, hypothesis testing. It's an area that blends logic, statistics, and systematic inquiry, enabling us to derive meaningful insights from our data. So, hypothesis testing is a fundamental concept in research that enables us to validate our assumptions and draw meaningful conclusions from the data. It's a skill that every educator and researcher should master to ensure the reliability of their work. Throughout the session, I will aim to make the concepts clear and relatable, and I welcome any questions or discussions as we progress. First, the learning objective of today's session. So first thing is we will start by understanding the foundational concepts of hypothesis testing. This will include what is hypothesis and why they are matter and the steps involved in testing code. Next, we will explore scenarios where hypothesis testing is applicable, helping you to identify when and how to use it on your research or teaching practices. We will also look at the statistical tools and techniques commonly used for hypothesis testing, ensuring you are equipped with the right resource to perform accurate analysis. Then lastly, we will discuss some of common errors made during hypothesis testing and how to avoid them, ensuring the validity and reliability of your. Let me explain how the session will go. We will cover everything step by step to make it easy to understand. First, I will give a quick introduction to hypothesis testing and why it is important in research. Then we will learn what is hypothesis and how it is used in research. Next, we will talk about what makes hypothesis clear and useful. I will explain the different types of hypothesis like null hypothesis, alternative hypothesis, and the things. And we will look at the key ideas like significance, significant level, p-value, and some other things. We will also learn about variables, their types, and how they are connected to hypothesis. Then next on, the steps for form a good hypothesis, and we will see how to use test hypothesis in simple and effective. This is a flow we will follow today to make sure everything is clear and easy to follow. So first, hypothesis testing is a systematic way to check if our assumptions are correct or not. In simple terms, when we have an idea or a guess about something, what we call a hypothesis, we use this method to see if there is evidence like data, which is support it. It is a process that relies on data to help us make decisions instead of guessing or assuming hypothesis testing. So hypothesis testing allows us to make a probability-based statements about the parameters of the population. This is especially useful in areas like social sciences, where we study human behavior, human social trends, and the relationship between the different factors. By using hypothesis testing, we can make informed conclusions and improve the reliability of our research. Let's talk about what is hypothesis. A hypothesis is statement or assumptions that we can test. It explains the relationship between two or more things, like how one affects the other. How one affects the other. It's like making a guess or prediction and then using data to check if it is true or not. A hypothesis helps researchers focus on their work. It gives a clear idea of what they want to study and helps them to design experiment to test their ideas. You can think of hypothesis as a possible answers to research questions. It is based on what we already know and can be tested with proper methods to see if it is correct or not. So in simple terms, hypothesis is a smart guess that guides researcher and help him to find the truth strong behind the testing. Now look at the why hypothesis testing is important. So hypothesis testing helps us make decisions based on evidence, not just assuming or guesses. It gives us a structured way to validate ideas. Then it adds credibility to research findings because the conclusions are based on data, not by options or opinions. And hypothesis testing takes raw data and turns it into meaningful insights, which is especially helpful in social sciences. It allows a researcher to compare groups, compare the behavior and the trends in a clear and effective way. By analyzing data, the hypothesis can help predict the future also. And it ensures that research follows a logical and systematic processes, making it reliable and thorough. Now, let us discuss about characteristics of good hypothesis. So as we already see, the good hypothesis isn't just a guess. It needs meet certain criteria to be in a research. A hypothesis should be easy and understanding and clearly written for without any confusions. For example, instead of saying exercise is good, you could say daily exercise reduce the blood pressure. And the second thing is capable of being tested. It should be something we can test using experiment or data, or if it can be tested, it is not useful for research. The next it states the relationship between variables. A hypothesis should show how one thing relates to another. For example, increased study times lead to better grades. It shows a clear relationship between the study time and the grades. Right? The next thing is limited in scope must be specified. It should focus on one particular idea or question, not try to cover too much at once. The next thing is a simple terms and noun fact. A good hypothesis should use a straightforward language and be based on what we already know. So it's easier to test and understand. The last one is the testing within a reasonable time. The hypothesis should be something we can test in a practical amount of time. For example, a study on impact of new teaching correct answer. By meeting these characters, a hypothesis became a solid foundation for reliable and meaningful research. Let's move on to types of hypotheses. So we can see the various types of hypotheses. In this, we have simple hypothesis, complex hypothesis, associative hypothesis, causal hypothesis, directional, non-directional hypothesis, empirical hypothesis, and last one, the null versus alternative hypothesis. The first thing, the simple hypothesis. simple hypothesis explains the relationship between just two variables, an independent variable and the dependent. It focuses on direct cause and effect relationship, but it does not go into the specific direction of the effect. For example, increased exercise lead to improve their health. So here, exercise is the independent variable and health is their dependent variable. These kinds of hypothesis is straightforward and easy to test. The second thing is complex hypothesis. These type of hypothesis is bit more advanced because it involves multiple variables. It explains how several factors work together or interact to influence the specific outcome. For example, interaction between genetic diet and their exercise may influence their life, right? So here, genetic diet and the exercise they're doing are the independent variable, and the life, their longevity is the dependent variable. These type of hypothesis is useful when studying phenomena influenced by the various factors. And the next one is associative hypothesis. These types shows that two variables are related to each other, but does not claim that one causes the other. In simply, the observes that when one variable changes, the other variable changes too. Think of connection or pattern between the variables, not cause. It simply says that one variable change is not impact the variable change of further. There is a correlation between income level and healthcare services they are taking. So those one getting high income may get a better healthcare services, right? And next one is causal hypothesis. This is more specific and claims a cause and effect relationship. It means one variable directly influence or change the another variable. To prove this, the researcher often use experiment or controlled studies. For example, the increase in the consumption of sugary drinks cause in increase in the body weight. Here, sugary drinks are identified as a cause of weight gain, and this can be tested. So it's called a causal hypothesis. And next one is a directional hypothesis. A directional hypothesis predicts the direction of relationship between variables. It specifies whether one variable will increase or decrease when another changes. In simple terms, it says that what kind of effect you can expect to see which direction. So, for example, the higher level of education lead to higher income level. The hypothesis predicts that as education level increases, the income level also will be increased. It's saying that there is a relationship goes on in one specific direction. So increasing education level cause to increase in the income level also, right? So the next one is a non-directional. A non-directional hypothesis, on another hand, does not predict the does not predict the direction of the relationship. It simply states that there is a relationship between the variables, but it does not say whether one will increase or decrease as a result of. It's more open-ended and does not suggest any specific pattern. For example, there is a relationship between social media use and the level of anxiety. So here, we don't know if more social media use leads to higher or lower anxiety levels. We just know, we just know there is some sort of relationship between these two, but we don't actually know whether the one thing is lead to another things increase. And next one is empirical hypothesis. An empirical hypothesis is based on real world observations and experiments. It is formed through what we observe in the world around us, and it is tested to check whether the relationship stated is accurate, or the main idea is that it is grounded in actual data, not just theories and ideas. So here there's an example shows that plant grow faster when we water with nutrient enriched water than plant with plain water. This is an empirical hypothesis because it is based on observing how plants behave in real situations, and how can be tested through experimentation to see if a relationship is true or not. So in this slide, next we are going to see the basic concepts of hypothesis. So in this basic concept, we are going to see what is population mean, and what is hypothesis mean, and what is null hypothesis, and what is alternative hypothesis. What are the types of errors are there, and what is significance level, and what is p-value, and how we have to interpret the p-value. So first, what is population? Before we are going into understanding null and alternative hypothesis, we have to get a clear understanding about what is a population. So the population mean is the average value of characteristics such as, for example, we may say height or score or income across the entire population. It just represent a single value that summarize the entire set of data for the population. The population mean is fixed value, but in many cases it is unknown because it is difficult and sometimes it is impossible to measure every individual in the population. Instead, we usually work with sample to estimate the variable. So, for example, how we are estimating the population mean. Now we look at the example. So consider a school with 1,000 students. We want to know the average score of 1,000 students in the school. The average is the population, right? But measuring every student's score is impractical. So since it is impractical to measure every student's score, we we are going to take a sample of this. For instance, we are selecting only 100 students randomly and calculate the sample, which is the average score of 100 students. We then use the sample mean to estimate the population. This is how we estimate the population mean when it is not feasible to gather data from the entire population. And the next thing is what is hypothesis? So the hypothesis mean is a specific value that proposed for population mean in a hypothesis test. It is an assumption or starting point of our research. We use this value as the baseline to compare the actual sample data. In other words, we can say we just set the hypothesis mean as the value we think the population mean might be. From there, we collect data and test whether the actual sample mean aligns with or it differs with the proposed value. So then why we are using it? Why we do use it? So we use it to check if our sample data aligns with our contract, aligns with our proposed value or not. The hypothesis mean gives us the reference point to test something against. For example, uh, to connect. So for example, to connect the population and hypothesis, the population means nothing but this is the actual average of the all students in this. However, it is unknown because it is not practical to calculate for every store. So we are taking sample mean. This is the average score that calculated from sample of say 100 students. We can easily compute this from the small group, right? So from the understanding of population mean and hypothesis mean, now we are moving into what is null hypothesis and alternative hypothesis. So hypothesis testing, two hypotheses are always formulated and they assert the opposite. These are called null hypothesis and alternative hypothesis. A hypothesis is a proposed explanation or prediction that the researchers make about the relationship between two or more variables. It acts as a starting point of investigation and provides direction to research processes. So let's say understanding the null hypothesis. So we can say that null hypothesis is the starting assumption of the hypothesis test. The null hypothesis, it suggests that there is no effect or no relationship between the variables being studied. It can say the null hypothesis is denoted as H naught, while the alternative hypothesis is denoted as HA or H1. If there is insufficient evidence to support the null hypothesis, it may be rejected. However, if the data doesn't provide enough evidence to reject the null hypothesis, further testing is required to draw definite conclusion. So the null hypothesis often suggests that there is no effect or no relationship or there is no difference between the variables under the investigation. So researchers typically reject or disprove the null hypothesis if the data supports the alternative hypothesis. These rejection set the stage for further experimentation or research that can help explain how the relationship or effect is interested. For example, let's say if we want to test the hypothesis mean, the population mean is equal to the hypothesis. So I can say it again. For example, let's say we want to test the hypothesis that population mean, which is equal to the hypothesized value of 100. In this case, our null hypothesis would be 100, right? This means we are testing whether the population mean is 100 and we gather the data, see if we can reject this assumption. Let's move on to alternative hypothesis. The alternative hypothesis is a set of hypotheses that are alternatives to the null hypothesis. It is denoted as a HA or H1. When we conclude that we should reject the null hypothesis, we are supporting the alternative hypothesis. If we accept the null hypothesis, we are essentially rejecting the alternative hypothesis. On other hand, if we reject the null hypothesis, we are accepting the alternative hypothesis. In essence, these two hypotheses are opposites, and our test process helps determine which one hold based on the evidence. So there are some possible alternative hypotheses for the null hypothesis. For the population mean and hypothesis mean is equal to 100. In the case, we are taking that population mean and the hypothesis mean is equal to 100. So 100. So here we have three possible alternatives. The first one is hypothesis, alternative hypothesis. The first alternative hypothesis is that population mean does not equal to the null hypothesis. The alternative hypothesis is that population mean is not equal to 100. It may be more or it may be less. The second alternative hypothesis is that population mean is greater than the hypothesis mean. It states that the hypothesis mean is greater than the population. Sorry, the population mean is greater than the hypothesis mean. And the third alternative is that population mean is less than hypothesis. These are the possible alternative hypotheses. If we take that population mean is and hypothesis mean is equal to understand this better, we see one example scenario. Suppose we are testing a new teaching method improves the math score with a sample of 50 students. So if we believe that our population mean is equal to 100, we are taking a sample of 50 students here. So here we are taking the null hypothesis that the population mean is equal to 200. So against the null hypothesis, we are taking our alternative hypothesis that the population mean is does not equal to 200. So then we have to compare the sample mean that is 100 with the hypothesized mean. So if the difference between the sample mean and hypothesis mean is significant, we have to reject the null hypothesis. It states that it clearly states that there is a significant difference between the null hypothesis. Sorry, there is a significant difference between the sample mean and the hypothesis mean. If there is a significant difference, we have to reject the null hypothesis. If there is a difference between the sample mean and hypothesis mean is not significant, we have to accept the hypothesis, which state that the population mean is equal to the hypothesis. Okay. For example, we take a sample of 50 students and their average score is 110, which states there is a significant difference between the sample mean and the hypothesis mean. So we have to reject the null hypothesis. So before moving into types of errors, let's take some polls. Kindly answer the polls and we will have 2 minutes of time. So thank you for your active participation. Uh, so let's see a small explanation about these questions. So the first question is, what is the primary purpose of hypothesis? So here the correct answer is, as majority, to validate the assumptions using the data. So the hypothesis testing is used to validate or reject our assumptions, right? So the researchers test hypothesis to see if there is enough evidence to support the result or reject the assumption. Okay. So the second question is, which of the following is a characteristics of good hypothesis? So here the correct answer is, as a majority of you selected the correct answer, it establishes a clear relationship between the variables. A good hypothesis clearly defines a relationship between the variables being studied and making it testable and measurable. Then the third one is, what type of hypothesis predict the direction of a relationship between the variables? So here the correct answer is directional hypothesis. As we already see, the directional hypothesis predict the direction of the relationship between two things, whether the C increase, whether it is decreasing by another. And next one is, which hypothesis is tested directly in hypothesis test? As we already know that correct answer is null hypothesis. Because as we already know, null hypothesis is the starting point of any researcher. First, we are going to assume something. It's going to be a null hypothesis. So next, we are moving into types of errors may occur in research. So there are totally two types of errors. One is type 1 error and another one is type 2 error. So the type 1 error is nothing but the rejecting the null hypothesis when it's actually correct. So when we are rejecting the null hypothesis, which actually true, is called type 1 error. And if we failing to reject the null hypothesis when it's actually false, it is called type 2 error. When we are when we fail means when you are not rejecting the null hypothesis when it is false, it is called a type 2 error. To get a better understanding about this, see the picture here. So the first is the null hypothesis is true. In first case, the null hypothesis is true. If it is accept the null hypothesis, then it is correct. There is no error in it. If the null hypothesis is true, but we reject the null hypothesis, this is called a type 1 error. The second scene is the null hypothesis is false. So if the null hypothesis is false, then we accept the null hypothesis. This is called a type 2 error. To get a better understanding, let's say about an example scenario, there is a production sector, okay? So the producer is producing the product and the consumer is buying the product. If the first scene is the producer is produce the product which is actually good product. Okay, there is no fault in the product. He actually produced the good product, but by error, the manufacturer rejected. Okay. He produced the good product which has no fault, but by mistake, if we reject that product, it is called a type 1 error. It is also called a producer error, a producer loss, because he actually produced the good product, but by mistake, he rejected. So it is called type 1 error or the producer error, producer loss. The second scenario is he actually produces a fault product. There is a manufacturing defect in that fault, but by mistake, the consumer buy the product. Actually, the produce has some fault, but by mistake, the consumer buy that product. It's called type 2 error or consumer error because there is some fault in the product, but by mistake, if he bought the product. So it is called type 2 error. So next we are moving into the level of significance. The level of significance is used to measure the risk of making type 1 error, which occurs when we incorrectly reject a true null hypothesis. It is called a level of significance. When we perform a hypothesis testing, we calculate a p-value, right, which helps us to determine whether the result are statistically significant or not. If the p-value is less than the level of significance, that is the level of significance commonly expressed as a percentage of 5% or 1% in some cases. If the p-value is less than the level of significance, we reject the null hypothesis. This means that the observed data is unlikely to have occurred under the assumption that null hypothesis is true. So let's see what's the p-value and how to interpret the p-value. So as we see, the p-value represent the probability, right? The p-value actually represents the probability of observing the result of the test or something more extreme under the assumption that the null hypothesis is true. It helps us to measure the strength of the evidence against the null hypothesis. To determine the hypothesis, here are the three alternative interpretations are there. If p-value is less than 0.01, okay. If p-value, which is the probability value, is less than the significant value, it just indicates that there is strong evidence against the very strong evidence against the null hypothesis. And the second thing is if the probability value is less than 0.05, 0.05 of significant value, it says that there is a moderate evidence against the null hypothesis. Hence, we are going to accept it, right? If the significant value is, if the probability value is less than 0.05, we are going to accept the null hypothesis. If a probability value is greater than 0.05, it suggests that there is a weak evidence or there is no evidence that means there is a null hypothesis cannot be rejected, right? So this is the way how we have to interpret the p-value. So here we are going to see that with the example. So for example, if the p-value is 0.03, which is less than 0.05 of level of significance, we can reject the null hypothesis because it says there is a strong evidence against the null hypothesis. In case if the p-value is greater than 0.05, that is here the example here in second example, it's 0.07, which is greater than 0.05 of significance value, it fails to reject the null hypothesis. That says that there is not enough evidence that strongly enough to prove the alternative hypothesis. So here see with the example scenario, so the scenario is a new drug is more effective than a current treatment. There is a scenario that there is a new drug which is more effective than a current treatment. So we are taking significant value as 5%, that is 0.05. If the p-value is 0.03, which is less than 0.05 of significant value, then the null hypothesis is rejected. It says that it supports the drug. That the drug is effective. In case if the p-value is greater than 0.05, it may be 0.07 or 0.08, then the null hypothesis is accepted. That means it not supports the drug. It says that drug is not that much effective than the previous treatment. So after this, we are going to see the variables. Let's see about what is variables and types of variables. In research, in research, variables are the elements. Variables are the elements or characteristics or the factors that researchers measure, control, and manipulate. These variables are crucial because they allow researchers to explore and understand the relationships or the pattern or phenomena within the study. By, ex, by, examine, by examining how variables interact, the researchers can gain insights and draw conclusions that supports or challenge the hypothesis. So the thing or the person we collect is called observation. Okay. So the every observation have their own characteristics. Every observations have the variety of characteristics. If the characteristics of if the characteristics of an observation is same for every member, then it means it is not vary. If it is not vary, if it is same for everyone, it is called constant. If a characteristics of an observation is different for group members, it means it's varying from everyone. Everyone have different opinions. It is called variable. Okay. So in research, variable are, as we already see in research, variables are elements and characteristics or factors that can be measured or controlled or can be manipulated for the research results. Right. Let's see the types of variables. The variables can be divided into two types, two main types, that is the categorical variable and metric variable. So the categorical variables represent categories or groups, means for example, it may be a gender or it may be their marital status or it may be their origin of country. They don't have natural order and can be measured numerically, just a category. So we can't measure the category. It's just a character. So we can classify the categorical variable into two things. The one is nominal and another one is ordinal. So for example, the categorical variable, here the one scenario that says which age group participants the most in online shopping. So here the variable is the which age group is doing the more online shopping. It is the variable. So we can give options as a categories. The group one, which is below 18 years, and group 2 is 18 to 35 years, and group 3 36 to 50 years, and group 4 is above 50 years. So we're categorizing the peoples by their age. So it's called categorical variable. And the second example is which platforms do users prefer for their professional network. So here the variable is the social media, the platform that professionals using for their network. So here the categories are the Facebook or Instagram, Twitter or LinkedIn. Which category of the social media they are using for their networking. So we are just categorizing the social medias. So these are the examples for categorical variables. We are moving into metric variable. So metric variables are numerical and allow mathematical operations like additions, subtraction, and divide, division. For examples, include age or income or height. These variables can be further classified into interval variable and ratio variable. Sorry, ratio scale. To understand this, there is some example scenario that says, what is the average age of participants in this survey? So here the variable is the average age of participants. We are going to collect the data. With the data, we are going to calculate the average of the participants. So here they are going to give only their age, maybe 20 or 25 or 30. We are going to calculate the average from this. We are going to do some mathematical things. So it comes under the metric variables. So another example, what is the household monthly income in urban areas? Say the variable is household monthly income. They just it may be 15,000 or it may be 25, 40 or 70,000. We are just going to calculate the income. Okay. So these are the things comes under metric variable. Let's understand the categorical variables and metric variables better. There is some approach we called classical approach. So in classical approach, we have the four categorical variables. One is nominal, ordinal, interval, and the scale, right? So, so these variables, the nominal, ordinal, interval, or ratio may be called as measurement levels. The measurement level refers to the different ways that data can be categorized or quantified or scaled in statistical analysis. These levels of measurement are used to determine the type of data that the that they help in selecting the appropriate statistical method for their analysis. When it is stated that if the order of the data, if sorry, if the order of the data value is undisputable, it is nominal. Sorry. It means it states the value of the data is disputable. If the data value is disputable, it is called a nominal data. It refers to lack of meaningful or a fixed sequence among the categories. In other words, when the order of the data is arbitrary or disputable, it means there is no reason to rank one category is higher or one category is lower than another. It can be classified as a nominal. In categorical or metric variables, the nominal scale is the lowest level of measurement. Here, the data are classified into distinct categories that do not have any specific order or ranking. There is no specific order or there is no specific ranking between the variables. This comes under the nominal level. Okay. For example, we may say gender or we may say marital status or the religion. These kind of things are comes under the nominal because there is no ranking between the gender. There is no ranking between the married. You may single, you may be married, you may be divorced. There is no ranking. We can't rank the variable. So it comes under the nominal variable. So sorry. So now, so next we are moving into if the order of the data value is undisputable. If the value is undisputable, then we have to check whether the data values have fixed unit of measurement. If there is, we have to check if there is any measurement of units are there or not. If there is no measurements, then it's called ordinal variable. So ordinal data or ordinal variable, we can say that the ordinal variable is undisputable with the order with the fixed units of measurement. There is no fixed units of measurement in ordinal. So ordinal data refers that it has a meaningful order or ranking, but the difference between the categories are not necessarily equal or measurable. There is some ranking will be there, but there is no necessary that it should be equal or it should be measurable. It should be in undisputable order. Right? So the categories in ordinal data have specific sequence or ranking that is meaningful. But unlike nominal data, the order can be disputed. For example, For example, in a survey, asking respondents to rank the satisfaction on a scale of 1 to 5, which one state uh, they are not unsatisfied, they are not satisfied with the thing, and the five says that they are very satisfied. In the order of responses, the one is lesser than two, and the two is lesser than three, and three is lesser than four, and the four is lesser than five. It says something is fixed and something there is a meaningful thing is there. So it's called ordinal data. There is an order is there. So it's called ordinal data. So then if the data value are fixed unit of measurement, we have to check the variable as zero value means nothing. We have to check the if the variable as zero and whether the value of the zero is nothing or it adds some meaning. If there is a no meaning for zero, it's called interval variable. So interval data or interval variable. So if the interval data has ordered categories with the fixed intervals between the values, but it does not have a true 0 point. There is no 0 point in between the variables. Then it is called interval variable. Right? So there is a fixed unit of measurement is there, but it does not have the true 0 point. The interval between the values are equal, meaningful in mathematics, such as addition or subtraction can be performed. But there is no zero value between. A zero value does not indicate the absence of the quantity, but the zero simply the another point on the scale. If there is a zero, it's not meaning anything, but it is another point on the scale. For example, in temperature, Celsius or Fahrenheit, the interval between 10 degrees Celsius and 20 degrees Celsius in the same, the interval between the 20 degrees Celsius and 30 degrees Celsius, which is 10, right? But the 0 degree Celsius does not mean the absence of temperature. It's just a point on the scale. It's just a point on the scale, not an absolute zero value. 0 degree Celsius also kind of point on the scale, right? So these kind of variables are comes under the interval variables. Then we have to check if the zero has a meaning. If the zero has a meaning, it's called a ratio variable. Here, the ratio variable is similar to interval variable. More or less, it is similar to interval variable, but as a true 0 point. In interval variable, there is no 0 point, but in ratio variable, there is a 0 point, which means that zero indicates the absence of quantity being measured. Okay. The fixed unit of measurement, like interval data, the ratio data has some equal intervals between between the values, and all arithmetic operations can be done. But a zero value means nothing or absence of the quantity. Here, the zero value means nothing. There is absence in the quantity. So therefore, the ratios between the values are meaningful. For example, we are taking a weight or we are taking height or income. Here, the zero means the absence of weight. If there is a zero, there is no weight. If there is a zero, there is no height. If there is a zero, there is no income. Like these, uh, can be comes under the ratio variable. We can say, for instance, a person weight 100 kg is weigh twice as much as a person who weight only 50 kg, right? So we can convert into a ratio data. And there is another approach also there, which is called modern approach. The modern approach to measurement in statistics and research builds upon the classical approach and emphasizes a more and flexible understanding of data and its properties. This approach focuses on concepts of scales of measurements and levels of measurements. In this, we have extra the so other than categorical and metric variable, here we have dichotomous variable, which is if there is a two distinct valid values, right? The variable has preciously two distinct valid values. Only there is a if there is a two distinct valid values, it is called dichotomous variable. So the dichotomous variable is a type of categorical variable that has only two possible outcomes of or categories. Like, so dichotomous variables also is like categorical variable, but it has only two possible outcomes, which may be true or false, zero or one, or it may be yes or no. These kind of things comes under the dichotomous variables. For example, we may say gender, male or female, marital status, married or unmarried, and response yes or no. These kind of things comes under the dichotomous variable. In dichotomous variable, mainly used in chi-square test, logical regression, and binary classification model. These kind of statistical tests needs the dichotomous variable. So after dichotomous variables, if the order of the data value is undisputable, if no, it is called nominal variable. Nominal variable. If yes, we have to check the data value as fixed unit of measurement. If the data has no fixed unit of measurement, then it is called ordinal variable. If it has a fixed amount of fixed unit of measurement, then we have to say it as a metric variable. So before moving into steps involved in hypothesis testing, let's have another code. So there is one question in both that how to decide a significance value. So it depends on the nature of your experiment and associate with the risk. If you want to take less risk, like you are in medical field, if you want to take less risk, you have to consider it as a 0.01 as a significant value. If you want to take very less risk, right? In medical field, we can't take much risk. So in medical kind of fields, if you want to take very less risk, we want to take 1% as a significant level. If we are researching in social sciences like it may be management or commerce, we may take 0.05 as our significant. This is how we have to take the significance level. So that 0.05 that indicates that just a 5% of risk of concluding a difference exists when there is a one. But 0.01 that indicates that there is 1% risk making it more straighter. So let's move on to steps involved in hypothesis testing. So here there are 5 steps in formulating the hypothesis test. The first one is setting up the hypothesis. The first step is to clearly define the null hypothesis and the alternative hypothesis. So as we already know, the starting point of a research is clearly defining what is our null hypothesis. And then we have to decide what is our alternative hypothesis. Right. The hypothesis should address the research question and specify the expected relationship between the variables. Then the second one is selecting the significance level. As I just said, the significant level is chosen typically 0.05 or 0.01, which determines the deciding whether the test result is statistically significant. If we want to take less risk, we are going with 0.05. If we ready to take some risk, we may go for 0.05. This level help us to decide when to reject our null hypothesis. The third the third thing is testing the statistic. In testing, a statistic is calculated based on sample data. Like the test, the test statistic is used to compare the observed data with the expected data under the null hypothesis. It could be t-test or it's a test or chi-square, depending upon the type of test you need to perform. And the fourth one is the critical value. The critical value is a point that determines the boundary for rejecting or accepting the null hypothesis. If the test statistic exceeds the critical value, we have to reject the null hypothesis. Then final step is decision. Based on the comparison of test and the critical value, we make a decision to reject the null hypothesis or accept the null hypothesis. If we have to reject the null hypothesis, it means if the test exceeds the critical value, then we have to reject the null hypothesis. If the test does not exceed the critical value, we have to fail. We are failed to reject the null hypothesis. Right. These are the steps of hypothesis. So let's see chi-square and ANOVA as our statistical tools. So chi-square test. Due to time constraint, we are not going to see everything. Today, I will conclude the session by just introducing you about chi-square test and one sample ANOVA. The balance things will be covered in next session. So chi-square is a statistical tool which is used to test the relationship between the categorical. If we have the categorical variable, if the both two variables are comes under the categorical, then we have to choose the chi-square test. Just compare and observe the data to the expected data under the null hypothesis. It just determine whether the difference are due to the chance or significant relationship. So chi-square test can be used for three main purposes. The one is to test the first is as a test of independence. The second thing is to test the homogeneity, and third one is to test the goodness of fit. So in chi-square test, we may say, as we say, two kinds of hypothesis. One is null hypothesis and alternative hypothesis. In chi-square, we have to mention it as an association between the variables. So we are taking two kinds of categorical. We have to say whether there is a association between the variables or not. If there is a no significant association between the variables, it is a null hypothesis. And if there is a significant association between the variables, then it is called alternative hypothesis. For example, we have two categories. That one category is savings and another category is income. We are just comparing the income of the person and how much the amount they are saving from the income. The both things are comes under the category. Sorry, the category may be up to 20,000, 20 to 30,000. How much the amount they are getting as income and how much the amount they can save with the income. These kind of categorical comparison can be comes under the chi-square analysis. In this, we are taking the null hypothesis that there is no significant association between the total savings and total income. Against it, we are taking an alternative hypothesis. There is a significant association between the total income and the total savings. And the second thing is tool is a one-way ANOVA. A one-way ANOVA is a statistical tool to compare the means of three or more groups. It determines if the observed differences are statistically significant or so. It may be two variable. One is a metric variable and another one is categorical variable. In chi-square, both the variables are categorical. But in one-way ANOVA, if there is two variable, the one is metric variable and another one is categorical. So, in chi-square, we take hypothesis as an association. We are comparing the variables and finding if there is any association between the variables or. But in one-way t-test, one-way ANOVA, in one-way ANOVA, we are testing that there is any differences between the variables or not. So here the null hypothesis says that there is no significant difference between the variables. Against alternative hypothesis says there is a significant difference between the variables. For example, you may have any profession, it comes under the categorical variable, right? You may a software engineer, you may a teacher, you may be a doctor or government employee, whatever the category you may comes under. And the thing you are comparing another variable is self expenditure. So here the expenditure is a metric variable. So we are comparing one categorical variable with another metric variable. So this comes under the one way. So we are taking a hypothesis. There is a no significant difference between the profession and their self expenditure as a null hypothesis. And there is a significant difference between profession and their respective self expenditure as an alternative. With this, today I come to the session. Uh, Balance things will be handled by tomorrow. Hypothesis testing. Kindly fill the feedback form for today's session. So there is one question in chat box that can we take a null hypothesis in a positive way? Yes, actually we can take a null hypothesis in a positive way. So we can frame in a positive way depending on how the research question or how the problem is stated. So if the null hypothesis, we know now, null hypothesis means there is no effect or no difference between the variables. However, it can be also framed in positive as a default assumption for existing in state. Maybe for example, we can say, as we already see, the new teaching method does not improve the student performance compared to the traditional method. In this, we may say this is positively states that the traditional method is equally effective or the new method has no impact. If we accept the null hypothesis, this is gives some positive states that the traditional method is equally effective or new method has no impact over the traditional method. So these kind of things we can take a null hypothesis in positive way also. So thank you for the participation. Kindly fill the feedback form. Thank you.
Thank you, thank you, Anand sir. Thank you, Anand sir, for your wonderful session on hypothesis testing 1. And thank you all participants for your active participation of this entire session. The next session will be on a Monday. The link will be provided in the WhatsApp. Kindly join on that day. Thank you all. Feedback link will be posted in chat box. Kindly fill it in.